I wrote out some of the notes, maybe easier for you to follow. So chapter 11, we're looking at the consumer side. We looked before at the production side with the PPF. If you recall, country has two goods. What's the maximum combination that they can produce? Well, now we're getting away from the production side and we're looking at the consumer side. So the question is, what limits what we can afford to purchase? So it's two things. One is our income, and the other is the price of the products. If you have more income, you can obviously buy more. If prices are lower, you could also buy more. In this example, you have a budget to buy two goods, and we're going to assume that all the money that you have in the budget is spent on those two goods. It's allocated in those two goods, so there's no saving in this model. So in this case, we have income, probably a better word is budget. We have a budget of $30 to spend on cereal and milk. A box of cereal costs $3 and a gallon of milk is $4. So I look at the combination of buying cereal and milk. Of course, if you buy no milk and if cereal costs $3 and your budget's $30, you can buy 10 cereal and 0 milk. And so I completed this chart, which I'm sure you can see. It's a constant slope. Every time you go down 2 boxes of cereal, you can buy 1.5 more gallons of milk. And then we can plot these points just like if we had a PPF. We can plot these points, and this is something called our budget line or income line. So I have cereal and milk, and once again, we can have 0 milk and 10 cereals, or the other axis, intercept, 7.5 milks and no cereal, and all the between points. So things that are on this curve, any point on this line segment is spending all the budget, and that's our goal, one of our goals. Any point outside of this is not affordable. So it's not attainable. Any point inside is affordable, but not desirable because we want to spend our entire budget on those two products. And what I just said is below on this page. And this example also illustrates the same thing for 2 different products. The question is now, what happens if the price of one of the products falls? Well, if the price of cereal falls, you can buy, if you don't buy any milk, you can buy more cereal. And if the price of milk doesn't change, then when you buy no cereal, buy the same amount of milk. Therefore, a change in the price of one product is going to cause the budget line to pivot or rotate. There'd be, the slope would change because it's not a parallel shift. And of course, if the price of cereal increased, then it'd be the opposite. If you bought no milk and all cereal, if the price of cereal is higher, of course you'd able to buy less cereal and there would be no change in milk. So this shows the price doubling of this example of water, and therefore when it goes, you can buy twice as much. So you can see that line, it pivots, and you can buy twice as much. This point doesn't change because the price of that product has not changed. So that's, once again, change in the price of one product, in this case water. If the price of water falls, I may have said it opposite a minute ago, if the price of water falls, you can buy in half, you can buy therefore twice as much water. So the line's going to pivot over, but the quantity of chewing gum is unchanged. So now a separate question, what happens if one's income changes? So if your income doubles, well, you can buy twice as many goods. So it would cause a parallel shift, and that's at the intercept. It would be a parallel shift where the slope is unchanged. There's a term not too important called relative price. So it's looking at the price of one good, shows how many of the other goods you must forego if you buy one more. So for an example, cereal is $3, milk is $4. If I ask what's the relative price of milk, so you take the price of that good milk, divide it by the price of the other good, in this case cereal, and it's 1 1/3. So if you buy one more milk, that 1 1/3 is not a price, that is a quantity. So anytime you buy one more milk, you're foregoing 1 1/3 cereals. In some economics classes, they use what's called indifference curves, but we don't use that here. We use something called utility. So utility is satisfaction. So how much benefit or satisfaction you get when you consume one more good. So total utility is the total benefit you get from consuming goods or services, and marginal, you hopefully know at this point, marginal is how much extra utility you get when you consume one more good. So the marginal utility is your change in your total utility divided by the change in your quantity consumed. So total utility is you consume more, your total utility increases, but since you get less satisfaction, it's going to be increasing at a decreasing rate, and it can actually decrease if you get causes you to get sick, such as food, eating pizza. If you eat too much, your total utility can diminish, but usually we just do it increasing at a decreasing rate. And your marginal utility, once again, that first slice of pizza, I get a lot of satisfaction, but as I consume additional pizza, I get less satisfaction, so my marginal utility decreases as I consume more. And this is shown on the graph, and also computationally. So for here, it gives total utility for water and chewing gum. So your marginal utility, we're going up by 1 unit, so it's just how much additional. So if you go from consuming from 0 to 1 bottle of water, your total utility goes from 0 to 15, therefore your marginal utility is 15. That second bottle of water, 15 to 27, so your marginal utility is 12, and the same thing on the other side, of course, for the chewing gum. So as I just said, we have diminishing marginal utility. As you consume more, your marginal utility decreases, you get less satisfaction. That's why the two curves, total utility and marginal utility, as appear here. Once again, a similar graph. Way back, we looked at the key thing with marginal at the midpoint graphing, and you can see they did that here. So the total utility for the top graph goes from 0 to 15. So therefore you get 15 units of additional utility in the marginal utility graph. And they do plot it here at the midpoint, which is a half. We're going to find out, actually, it's going to be easier and better if we don't do that, not just in the graph, but in the table. So when you do that additional utility, just put it at the right endpoint, just like I did in the table above. So if you get 15 more units of utility, if you go from 0 to 1, you're just going to plot it at 1. You'll see that in a future example. Okay, so this is really the crux of the lesson. The goal of the consumer is to maximize within their available budget their total utility. You must use this two-step utility rule. You can't just do all the combinations and calculate which is the biggest total utility and give that as the answer. So the first thing is you have to spend your entire budget. So that means you must be a point on the budget line. And the second thing is you must equate the marginal utility per dollar. So the marginal utility is the marginal utility of the good divided by the price, the selling price of that good, for all combinations. And then you do the same thing for the other good. When the two of them are equal, then that is the point that's going to maximize your total utility. So a separate question. Suppose Tina has her marginal utility for gum greater than marginal utility per dollar for water. So I just made up an example. So our marginal utility for gum is 12, and the price of the gum is $2. Once again, I'm just making this up. And for water, at some combination, her marginal utility is 10, and the price is also $2. So the marginal utility per dollar, of course, 6 is greater than 5. So the question is, at that point, she's getting an additional margin utility per dollar of 6 is greater than water. So should she consume, we want to equate them. So she could consume more water or gum. We'll realize as you consume more, your margin utility decreases. So my gum, the value is too big. The price isn't going to change, so it's only my numerator. So in order to get these to equate, I need my gum to be a smaller number, margin utility, and my water to be a bigger number. So since consumers consume more, your margin utility decreases. Therefore, we want to consume more gum. Because if her margin utility decreases, then maybe her 12 becomes 11, so it'd be 11 over 2, and her gum, if she consumes less water, maybe it'd be 11 over 2 and they'd be equated. So here's a practice example I want you to work through. So it starts off giving you income of $30 with the price of movie of 6 and soda of 3. So from that you have to make the budget line. So to do all your combination of points. And they use step 2, the table, the chart to do that. Then you have to compute your margin utility. So you're given your total utilities. So you compute your margin utility. Once again, we're not graphing at the midpoint, plotting it, we're just doing it from 0 to 1, get 50 additional units. So we're putting that right there at 1. Do it for the other product. Then you're going to compute your margin utility per dollar. And then you're going to find the combination where they are equated. And you can do all that, take a little time. You can do all that on this page. I have a table set up for you. And then the second part is what happens if the price of movies decreases from 6 to 3. And so this one's actually already done for you. You can see the combination that is obtained. It should make sense whether or not you're going to get more or less of the movies. And the last thing is, and this is not too important, it just shows how a demand curve can be created from margin utility analysis per dollar. So the first time we had the price of movies was $6. Lisa bought 2. That should be your answer for the top one. So we plot that point. $6, 2. Then it's what if? What if the price of the movies changed to $3? Well, then we found out we bought 5. That was on the previous page. And therefore you can see a demand curve, as we know, is downward sloping. Okay, then I want you to do all the AP questions that follow on this page and the pages that follow. And answers are below.